When you use two-way ANOVA, you examine the effects of your two predictor variables concurrently. You can also determine if the two predictor variables interact with respect to their effect on your response variable. This possible interaction means that the effect on one variable depends on the value of the other variable. For example, this interaction plot for strength shows the average breaking strength of wires over different levels of heat settings for high and low alloys. The high alloys are denoted with the solid blue line, and the low alloys with the dashed red line. You can see that the average breaking strength of the wire for high and low alloys shows the same change across different levels of heat setting. When you see this parallelism, you can say that there's not an interaction between alloy and heat setting. In this plot, however, you can see that the breaking strength for high alloys decreases as the heat setting increases, but the breaking strength for low alloys increases as the heat setting increases. This indicates an interaction between the variables alloy and heat setting. When you analyze a two-way ANOVA with interactions, you first look at any tests for interaction among the factors. If there is no interaction between the factors, you can interpret the tests for the individual factor effects to determine their significance or non-significance. If an interaction exists between any factors, the tests for the individual factor effects might be misleading due to masking of these effects by the interaction. This is especially true for unbalanced data.